Hello again, everyone. Today we did a onboarding session for Spike. We discussed, lots of stuff. So I'll do a quick demo about the overall setup that we went over and try to show you how we can deploy Spike and test it as a developer, essentially. So in our setup, let me briefly go to the kind of overall high-level diagram of, what kind of a setup that we have. So we have two machines in the demo system that we are going to use. One of them is what I'd call the admin VM, and the other is the tenant VM. So the admin VM will have a SPIRE server on it, and it will be hardened. By hardened, I mean entry to it will be audited. The SSH will be limited to a certain IP address. The users that can access to that VM is a limited set of users, and they are highly secured and highly guarded. And the VM itself is also guarded. It might even be air-gapped, or it might not have outbound access, but it might just have enough access to have a SPIRE server to manage workload identities, essentially. That is the administrative VM. And the other is the tenant VM. The tenant VM can be anything. It can be a web application, some automation server, something that needs to maintain and keep secrets. Tenant VM is still security of it is important, but it is not as important as the admin VM. And there are two personas that interact with those VMs. One of them is our domain administrator, and the other is the tenant administrator. Tenant administrator will use, let me find my arrow key, will use Spike Pilot to enter, create, delete, update, and list secrets. So the tenant administrator will be managing secrets, and the domain administrator will allow or will authenticate the tenant administrator to manage secrets. So unless the domain administrator grants access to the tenant administrator to use Spike Pilot, the Spike binary, the tenant administrator won't be able to use anything. As we do the demo, it will be clearer. But this kind of separation of responsibilities gives a really neat security posture, and it kind of makes things more manageable. For example, if there's something happens with the credentials of the tenant administrator, then the domain administrator can revoke the capability of the tenant admin to use Spike, and then the tenant admin can't be able to use Spike until the issue is rectified, essentially. So that's the model. How this overall thing will work is domain administrator will register or unregister SPIRE server registration entries for the workloads here, like the Spike Pilot workload specifically. So what the domain admin will do is they'll shell into the machine and then create entries on the SPIRE server. So those entries, let's assume that this box is a registration entry. That registration entry will mean that the Spike Pilot will be able to talk to Spike Nexus and establish an MTLS connection and securely exchange material. Without that identity, Spike Pilot will not be able to establish that thing, and the identity will be linked to the Unix user of this tenant administrator too. So let's say I'm trying to find a color. Let's say, I don't know, this is the user account. This box represents the user account of the tenant administrator. As a tenant administrator, I enter the system using my username and password, and then I have, I don't know what, I have a Unix user ID, group, and other permissions, essentially. And I am a legitimate user on that tenant VM, tenant virtual machine. So this registration entry here will link this user ID group of the admin and also the binary. So the binary, for example, will have certain attributes. Let me create a box for that as well. For example, what kind of attributes that our Spike pilot binary can have? It can have a SHA hash. It can be on a certain Unix path. Or the binary can be run under a certain group or maybe certain user. So this registration entry will contain attestations for all of these. In practice, what this would mean is unless the Spike pilot executable here is being used by this tenant administrator and the executable that you see here has a specific SHA hash, is under a certain directory, it won't be able to get a certificate. And if it doesn't get a certificate, it won't be able to establish this MTLS connectivity that you see down here. This way, without using any credentials, like without using any root token, service account, administrative token, or whatever, just using the Unix credentials of the tenant administrator, we are able to securely manage secrets in a virtual environment, essentially. So how this happens behind the scenes is there is a SPIRE agent here, and let me again draw a box. Let's say let's say this box represents the Linux kernel. Let me write here, or inside it maybe, Linux kernel. So to attest that the binary is the binary that it's claimed to be, SPIRE agent will query the Linux kernel and say check the attributes of the binary that has a certain PID. So how that happens is like once the application is brought up, it will connect to the SPIRE agent and ask who am I, and then SPIRE agent will query the kernel and ask the kernel, hey, I have a process asking for its identity. It has this PID, this process ID. Can you give me the details of that process? And then the system will give the details of the process to SPIRE agent, and then it will correlate that with the SPIRE server and check, ask SPIRE server something like, hey, I have a process with this username, group, SHA hash, and other Linux attributes. Do you have a registration entry for that process? And since our domain administrator has created the registration entry, SPIRE server will return yes, and also it will return a certificate, and SPIRE agent then will deliver the what's called in SPIFFE lingo SVID, SPIFFE Verifiable Identity Document. And SVID is like a fancy way of saying X509 digital certificates to establish TLS connectivity. So SPIRE agent will return a certificate to pilot, and the same kind of negotiation also happens with other components of the system as well. So the Spike Nexus here also has its own SVID, and that's why these two folks can establish a mutual connectivity, MTLS. So that's the gist of the security model of this system, and as we demo stuff, it will be clearer. But yeah, that's that fun. So let me go to the virtual machines that I have. So this is the tenant machine, which is also my development environment. And this one, so to go through them again, this is the domain admin's machine, which has a teal background. And this one is the users, the tenant admin's machine, which has a more brownish background. That way you can mentally split them apart in your mind. So I'll start with the domain admin. I have this Spike project here. I just cloned the project. Let me see. Story grab clone. So I cloned 2 projects down here. One of them is Spike, which is in this workspace Spike folder. And another project that I cloned is SPIRE, because we need a SPIRE server and SPIRE agent to be able to run SPIRE essentially. So first, let me build SPIRE. Yeah, you can get the binaries from SPIRE from various sources. You can, if you go to spiffe.io, you can find the way to get a SPIRE binary to your system. But in my particular case, I am running on a ARM64 Linux machine, which is not quite standard. So I had to build the binaries myself. So that's why I cloned SPIRE project. So I have the entire project down here, and the building the binary is you just run make build, and it just generates binaries inside this build bin folder. Then you can register it to your path. So I have 2 binaries that I use, SPIRE Agent and SPIRE Server. I am not using OIA OIDC discovery provider yet. Maybe later down the line we may. But just building it will give you the binaries. And the rest of the workflow that I have is inside this Spike folder. So inside the Spike folder, I have a hack folder that I manage certain scripts. So one of those scripts is let me list them like this. One of them is to start the SPIRE server, since this is the administrative machine, and if you see, we have SPIRE server on the admin VM. So we are going to start SPIRE server here, and we are going to start SPIRE agent in the other VM. So for this, I have the SPIRE server start function, and after starting the server, we need to register. We need to create those registration entries, and that is this SPIRE server hydrate script. So let me cat the script cat hack SPIRE server start, and it is just doing some cleanup, and then we run SPIRE server with a certain server configuration file, and these are available on the web. You can just go to, let me open up a browser, https github.com SPIFFE SPIKE. You can go to this project, and you can see the source code as well. The hack folder is the same hack folder that I am talking about. You can download and play for yourself as well. So that will start the server. Let me start it. Hack SPIRE server start, and now I have a server running. Let me again list what I have in my hack folder. There is a show SPIRE server registration entries kind of script. I can run that one as well. Hack show SPIRE server entries. It will say there are no entries, and if we go back to our diagram, for our user to work with Spike, and even for Spike Nexus to be able to talk to SPIRE agent and other Spike components. For example, there is a Spike keeper, which is not in this diagram, but I can just draw it here. Spike keeper. Even for Spike Nexus to be able to talk to Spike keeper, both Nexus and keeper need to have registration entries in SPIRE server. We don't have it right now, so as a domain administrator, we are going to create those registration entries as well. So let me first show the script. Clear cat hack What's that one? SPIRE Server Hydrate. SPIRE Server Hydrate. It does a bunch of stuff. I commented out certain things to show how things work better. So I leave them commented out. So the hydrate script right now generates an agent token. Let's start with that one. Let me first show this registration entry creation script, but I'll run that separately. I'll first create the token, but let's see at least how that script looks like. Cat hack register SPIRE entries. So that script creates two separate registration entries for our SPIRE agent, and so this registration entry means that if a process is run by this user ID, it's running under this Unix path, and it has this SHA hash, then it will be able to get a X509 certificate that is associated with this SPIFFE ID. We are running these selections before giving that process the ID. Eventually, we query the environment that the process is on to get a identifiable proof that the process is what it claims to be. So we create two entries. One of them is for keeper, and the other is for nexus. And as long as these entries can validate the process, so that the agent will tell SPIRE Server that the process has certain attributes. It will say my process has a user ID. It is under a path, and it has a certain SHA hash of its binary. And if all of these match to the registration entry, then SPIRE Server will happily give an SVID certificate to SPIRE Agent, and SPIRE Agent then can deliver that SVID to the workload that is asking for its identity. Before that, I want to generate a token, and this token will be used to establish a trust relationship between the SPIRE agent and SPIRE Server. Let me cat hack generate agent token script. So what this token script does is we create a token file, and then let's see, token. We use SPIRE Server token generate for this SPIRE agent SPIFFE ID, and whatever token that SPIRE Server generates, we write it to a token file, and we change mode that token file to 600 to make it more secure. But essentially, when we run the script, it will create a unique token that we will give to SPIRE agent out of band. So I'll run hack generate agent token sh. I have generated the token, so let me cat that one, SPIRE agent join token. So I have my token here. Let me copy it, and then I'll go to the my other server, which the tenant administrator will be using, and I have a join token down here. I'll override that one, SPIRE agent join token. Let me paste the one that I copied, so the token has changed. So since I have changed my token, now I can start the SPIRE agent cat hack SPIRE agent start sh. So what it does is I'll just scroll to the bottom of it. We do a bunch of checks, but it's all about checking the validity of the token file. Once we have the token file, we run SPIRE Agent run with a configuration file, which you can check, separately. It's in the repository, and using this join token. So let's do that. Hack SPIRE Agent start. Okay, now I have a SPIRE agent running here. So I have an agent here, and I have a SPIRE server running on the other machine. So what I'll try to do is, let me create another terminal. So I'll split this one into two, split down. I have my keeper and nexus binaries. These are two binaries of the system. So I'll start keeper here, and I'll start nexus here, and they'll start, but normally they should be more chatty. Like you should be seeing nexus, asking keeper something, and keeper sending some request response. That interaction is not happening here because neither nexus nor keeper were able to get their SVIDs yet, because we haven't created the registration entries. So what I'll do is I'll go back to my administrative server, and then create those registration entries. But first I need to find the name of that script. Register SPIRE entries, I guess. Cat hack register SPIRE entries. Yeah, these are the two entries that I need to do. So let's run that script. Hack register SPIRE entries, and now I have two entries for, like, here, like one here and another one here. And if you look at it closely, like one of them is for keeper and the other entry is for nexus. So that's that one. But I have my entries. So if I go back to my tenant server, now I can see that these two folks have started chatting with each other. They are sending requests and getting responses. So life is good, everything is fine. But my purpose was not to let Nexus and Keeper talk to each other. My main purpose is to create secrets. And to create secrets, I have a binary called SPIKE. Let me try to use it. But again, I cannot use it because I don't have a registration entry for my super user on this machine. So what I'm going to do, I'll follow the same workflow. I'll go to my admin server, and as an admin, I can assign a registration entry for the tenant administrator. So let me see which script that can do that. And that one is this register SU, registering super user. So let me first show the contents of that script. Cat hack register SU. That does a similar attestation. And if our binary is SPIKE and it has this SHA hash that we computed beforehand, then give that binary this super user role so that it can act as a super user and create, delete, update, and list secrets. So let me do that. Hack register SU, and now I have a entry for that one. Actually, I can show those entries as well. Hack show SPIRE entries, and now if we see, we have one entry for SPIKE keeper, another one for nexus, another one for the SPIKE binary itself, which is SPIKE pilot, and another entry that we have is for the agent itself. So we have a neat system that manages these identities at scale. So let me go to the development machine, and now you can see that my hanging up process is responding to me, and I can get a response. So let me try to use it. Clear. For example, I want to SPIKE get tenants Acme DB creds, and it will say, by the way, these logs are you see these because our log level is debug. If our log level was something other than debug, you wouldn't be seeing this kind of verbose detail. What you all would see would be just hey, can you please initialize this system? And it makes sense. I am the first tenant administrator, so I need to initialize Spike. So let's do it. Spike init. Now it initialized the system. It creates some recovery material. I won't dive into the details of this because this flow will change, and I'll create a different tutorial / demo about the new flow. So I initialized it. So let me create a secret. Spike put tenants acme db creds username root password spike rux, enter, and now I can get it. Spike, for example, spike get tenants acme db creds, and now I can get the password and the username as a list. So far so good, but let's say as a tenant administrator, my job is done, and as the domain administrator, I don't want this tenant administrator to create or modify and update secrets anymore. Our system is, I don't know, there are certain regulations that we need to adhere to. So as soon as the tenant administration's job is done, I want to unregister that person so that they won't be able to fiddle with the system anymore. So for that, we have an unregister script, cat hack unregisters su, and what that does is it will first find the entry ID from the list that I showed you. So it will search for the entry ID that has a certain SPIFFE ID, which is the super user SPIFFE ID that you see here. And if it gets that entry, it will run SPIRE Server entry delete, and it will delete that entry. So let's run that one, hack on register super user, and now it says it deleted the entry, which means if I go back to my my tenant machine, and if I try to use Spike again, it should hang up because it cannot get an SVID. And that's the beauty of this security model. I can be root on this machine. I can have whatever power that I can have on this machine, but as long as I don't have an SVID, my powers are useless. I cannot use Spike, I cannot read secrets, I cannot create secrets. Any secrets that have been created are already in Spike, so any workload that has an SVID is able to consume those secrets still. So there is nothing changed. It's just my credentials as an administrator is not sufficient to get those secrets, which gives a really neat security model. Further down the line, you can link this to like an OIDC server, for example, and this way Spike as a system doesn't have to maintain any kind of username password or any kind of root token. What that means for an operations person is you don't have to wake up in the middle of the night to enter a root key for your secrets manager because it has locked itself or it has sealed itself, because there is no root key. The system works seamlessly behind the scenes. There is a root key, but it is neatly managed in memory and redundantly backed up through a cluster of keepers, which I will dive into its details later down the line. It's not the topic of this demo, but overall, it makes the operations people's lives easier. It helps you sleep more, and it keeps your secrets secure. But as far as demonstrating how we can create a demo development environment and create registration entries, run two separate servers in separate machines, and use two personas, one domain administrator and another tenant administrator, to show how you can securely create secrets on a Linux system goes. That's all I have to share for this demo. Until next time, keep your secrets secret.